Hey everybody, it's Justin from Built, and I haven't done a 3D printer video in a while. I believe that 3D printers are a great tool for in the shop, both for solving problems, making tool holders, adapters, everything dust collection. So I wanted to get back into that a little bit today. We're going to build two different tool holders. Number one, we're going to find a solution that will wall mount a whole bunch of our squares and rulers and things that are skinny and honestly very awkward to store. And then we're also going to make some sort of cubby shelf system that we can do small parts, and we'll be able to daisy chain it so you can use as many of these cubbies as you like together. Now, in order to do that, when you're making tool holders, you need to make a decent sized one a lot of the time. And this is the largest print bed that I currently have in the 3D printers that I own. This is a normal size print bed, but in all reality, it is not that big when confronted with larger tools and stuff. So I contacted Elegoo, and they were nice enough to send out their Neptune 4 Max. And Max stands for, oh baby, maximum print size. So this is a giant XL size printer with not an XL size price tag either, which is pretty cool. I think it's $439, which in the 3D printer realm, this smaller one is double that price tag. So you get a lot of volume here, which means I can make larger holders in one print without having to break it up into multiple prints and then gluing it together. So much better. So we're going to look at this printer a little bit, and then we're going to jump into Tinkercad. That is a free educational 3D modeling program. I keep everything very beginner friendly when we're talking about 3D printers on this channel. So I'm going to go through designing one of these holders for you and show you how it's really only a couple steps. It's very easy, and you can really accomplish a lot here in the shop with very rudimentary shapes. And then as you go along and as you alter files that are already pre-made by others, you'll advance and learn more skills as you're going along. So let's get into 3D printing today on Built. So the Elegoo Neptune 4 Max, the Max for just maximum size here. The bed size is 420 by 420 by 480, or in Imperial that is 16.5 by 16.5 by 19 inches. That is a huge space to be able to print very large size prints. Now, when you're dealing with such a large space, obviously this bed has a huge amount of space that it needs to heat and stay consistently heated. Through the magic of video editing, I've actually been using this for the past 5 days already, doing our prints for this video. I'm in this shop in my garage. It is January, and this week it is getting down to 0 in New Jersey. It is ridiculously cold. That's why I'm wearing long sleeves out here. Even though I have an HVAC unit out here in the shop, it's just can't keep up. It's too cold out here. It's like 60 degrees in the shop. So there have been a lot of temperature swings over the past 5 days, but yet I did not have any failed prints. And in fact, I actually ruined one of my prints, and it was my fault because I tried peeling it off without taking off the bed first and bending it. And that just shows that it had really good adhesion on here and good solid temperature control. Some of these prints that we're going to be doing in this video take a full 24 hours to print. So as that temperature changed in here, this was still able to stay consistently hot and consistent all the way through. Now, because this is an open 3D printer, not enclosed, you can't do all filaments with this type of printer, but there are a very long list of filaments that I'll put down below, all of your standard types for the most part. This has a detachable, magnetically held in place touchscreen, which is pretty big and nice. I always like when they are detachable. It uses Wi-Fi data as well as like Ethernet port, as well as USB-A in the front. So good connection options. The top has a light bar built in, which is a nice little accessory. And especially because this is a jumbo XL size printer, this has some stability rails that are mounted in the back, and that is to just make sure that you're making this structure as rigid as possible, especially as it's moving quite a bit away from the majority of the weight being down here at the bottom of the bed. This has a nice fan bar right here as well. This can be turned on and off both physically and in the software depending on what type of filament you're using with this. The print head has a dual gear extruder, and it gets up to 300 degrees Celsius. Up top we have a filament runout sensor, And this machine runs at a maximum of 500 MMS, which is still pretty respectable. There are many machines in the current generation of 3D printers that get up to 600 MMS, but if you have been using 3D printers, you know that you're really only running at that fast if you're doing a low quality print that you're just trying to crank out. Most of the time we are still slowing it down to 400, 300, 200, because if you're trying to get good quality, you can't run around crazy fast, especially with how big this is. The printer itself has done a great job. So in the 5 days that I've been running it, no issues, great print quality. So I've been very happy with it.
All right, so we're here in Tinkercad. This is a free website, free program. This is a great solution to be able to learn how to 3D design in. I am still a novice at 3D design myself, but I do have a basic enough understanding where I can show you how to make some things. And so, like you see in a lot of these designs that I have in here of things that I've made, it's very simple shapes. You don't have to go crazy. It's really easy to accomplish tasks with simple shapes. And then as you get more educated on the program, as you get more comfortable, you can then expand and, get more complicated with stuff as your skill level goes up. So what we're going to do is we're going to jump in. Of course, it makes all these really weird names in Tinkercad for some reason. We're a frantic Crift Robo. So what I'm going to design is my holder for my different squares and scales and things like that. They're oddly shaped. And so what I'm going to do is start with a simple shape for my back plate. So I'm grabbing a cube, a box right here, and I just place it down on the table. So I'm going to enlarge it. I'm going to do this really fast, so just so you get a good overview. But obviously, you see the actual measurements here. You can double click on it. You can say, oh, I want it to be 75, and it'll make it exactly 75. So what you should do is start by doing that, making it exactly the sizes that you want. But I'm just going to freehand it just for this example. So I made a flat back here, and I'm going to treat this like the back that's going to go against the wall. And then I'm going to grab another cube, and here we go. And this cube, I'm going to design it to be the shelf that the tools actually sit on. So I'm just grabbing and generically pulling things out. So now I have two rectangles, and the first thing you want to understand is they are still separate objects. And you can change the color if you want to too, just so that you understand that they're separate objects. They have not been attached together. What I'm going to want to do at a certain point, though, is grab both of them and group them, basically turning it into one solid structure. So now they both turned red again at that point. So we have our back. This would be kind of how we're looking at the tool right here, or the tool holder. So we have our back, and then we have the piece that extrudes out in the front. And so now I need to make a whole bunch of grooves for my tools to be able to be inserted in. And so you can grab any shape on here and tell it to be a hole, or they have two up here that are already like that. I'll just grab another box, but now I'm going to tell it to be a hole. And so basically what this means is this is a subtraction element. Whatever I put this on, if I group them, it's going to delete it. So, I just kind of threw that box in there and it got rid of it. So I'm just going to undo that. And so what I plan on doing is, first off, I want to grab this little arrow so I make it rise up. I want to make it float. And so again, I would measure exactly what I want to do. I don't want to subtract directly against the back plate here. I want to leave a little bit of room. I'm going to bring my box into the middle of this wall so that we know that we're going to delete it. I'm going to bring it all the way up, and I'm going to make it pretty skinny. Now, again, I would measure the thickness of my tool that I'm going to hold here. That way, I'm making sure that I'm making it exactly the right size. You obviously want to maybe make this number just a slight bit bigger because you don't want it to be too tight. But once I have this item here, if I combine them, there we go. We have this slit, and that would be great for me to slide in maybe like my compound square or something. I'm going to undo this because I want to just keep copying and pasting. And as I copy and paste, you'll notice it's at the same height as the previous one. So in this particular design, I want to make sure that all of my tools have the exact same depth of cut in this recess. I also might want to make some of them a little bit bigger, some a little bit smaller, things like that, based on the tool that I'm going to have inside here. And then, of course, I'm also going to want to make sure that my spacing is either equal or, just appropriate for the size of the handle of the tool that I'm going to have in here. But again, I'm just showing you a quick example of how we could do this. We'll copy this one again, throw it over. All right, so we're going to grab everything, hit group, and there we go. We have basically our hole there. Oops, you can see one of them didn't go all the way through. So I'm going to undo that. Make sure that I drag that guy back, grab it all again, and group. There we go. So my tools will be able to sit and stick through here, since all of these are kind of thin, long tools that are obnoxious to hang up. Now, if you think about building anything with woodworking, a butt joint right here, kind of basically what it is not the strongest, especially the longer that we make this. So there's going to be weight out here pulling down on it. And so we want to give it a little bit more support. So I'm going to grab another shape. So they have all these great shapes that are already available to you. I'm going to grab a wedge and plop it down here. So this wedge, first off, we need to rotate it so that it lines up with my design. And basically what I'm going to do is give myself a support diagonal that we're going to have here. We need to make sure it's obviously under that line that we made all of those grooves at. We're going to look underneath and, ooh, we're kind of sticking out underneath. So we're going to raise it up a little bit. Cool. Probably need to shrink it down just a teeny bit because I raised it up. There we are. And we're just going to group it back together. There we go. So now we have a little bit more support from the side. In the final version, I might do a little bit something more beefy, but this was just, again, a quick example. Now we need to be able to mount this. If we're mounting this to a French cleat or just screwing it to the wall, we still probably should have a hole. When you're dealing with 3D printed material, you'd rather have that hole than like drill through it, for example, because it's actually going to support that hole when creating it with additional side layers rather than it just being you drilling into a void. So here I'm descending a cylinder into this. I made sure that it poked all the way through. We're going to copy and paste that. Now we'll grab both and we will combine them. And now we have two fun holes. Really, you could stop right here. This would be more than good enough. Obviously, you can see that, I'm not being precise right now, so things are sticking out and whatever. But again, we're just doing a rough kind of thing on this. This really didn't take that long. You're obviously going to take a lot longer because you're going to be paying attention to your measurements on all of this. But by being able to select items and then changing the numbers on them directly. So going in here and saying this is going to be a 10, this is going to be a 12. And of course you can change up in the settings if you want it in metric or imperial. It makes it really easy and precise for exactly what you want to do. So we're overlooking at my final project right here. I actually designed it on its side, but when I finally did make this, I ended up rotating it and printing it on its back, just like I showed you how I was designing before. The Elegoo Neptune 4 Max is huge, and so you can see this is like my traditional printer size, but I'm able to print giant objects like this. So you can see that I made definitely a beefier inlay here. And so what I did was I waited to subtract this space in between until after I added that in. That way, when I subtracted the space, it subtracted from both the wedge shape that we added in here, as well as the rectangular box that we have jutting out. And so I think this is going to give a lot more support to the structure. I added in 3 recessed holes here, and you can see that, we recessed it so that we could use a, like a flathead screw, stuff like that. It would recess itself. Now, how do we do this? Very, very easy. So I did the cylinder like I showed you before to make the hole all the way through. And then you could just grab a ball like this, turn it to a hole. So we're going to remove it. And then I'm just going to basically move it to where it's just kissing the side here. So we're just going to do something like that. You can tell from the shadow that it's going to remove that. And so if I group these two together, there we go. So you can see that divot was made there. So pretty easy way to do that recess. You also notice that I made varying widths for my openings in here. I have bigger openings over here, medium openings, and then a couple skinny ones at the end. And that's all based off of the tools that I'm going to be using with this holder. If you want to download this file, I have all the files from this video linked down below, so you can download this file and use it for yourself. But let's say you need all bigger openings. Load this up into Tinkercad. Go over here and grab a box. Make a rectangle to whatever height you require for this. Throw it right, over here. Let me get it up there. There we go. And then just subtract it. And you will be able to alter this file. I'm doing it real quick here, but all right, success. So you can see that I made it a lot bigger than the previous one was. So being able to edit already existing files to your needs is a fantastic way for you to be able to learn.
All right, the holder is printed and the print came out absolutely perfect all the way around. No issues, no offsets, no banding, no nothing. So awesome. And I'm really happy with how stable this is, especially since we added in this beefy, kind of diagonal right here to help support this. I might even end up elongating this in a design just because, this is on here, but it is sticking off a decent amount. But I can tell you that it is definitely on there really well. It would definitely have fallen off if it weren't, but just for some extra support, I might do that. I've also made it to where on this file, if you choose to print this, if you download it, you can screw it directly to the wall, or you can do what I did. I included some French cleats in here too. So there'll be 3 French cleats. Here's one of them here. And I did this to be able to bolt together with a 5mm bolt and nut. You have a little recess back here for the nut. You can just slide in there. And here we have our holders. I think it came out really well. All right, so keeping things simple, in our next tool holder, as we want to make it, I wanted to do cubbies with drawers that also act as a shelf. So if we wall mount this and we put a whole bunch of these together, you're going to have a platform that you can set things on top of, as well as have drawers that are coming out of the inside. So to make this cubby, you're literally just taking a cube and then you're inserting another smaller cube inside and deleting it out. That's it. It is about as simple as you can possibly get from like a design and shape type of setup. Now, on this one, again, the Neptune 4 did a fantastic job on printing this out. No issues whatsoever. I think that I really, really am happy that I have a larger printer now, because I could never print this on another printer. And honestly, I can get a third one. So I could design one that is 3 cubbies long, and I would be able to print it on here. I might even be able to get 4 cubbies tall if I did it like this. Being able to do a print in one go is really, really nice. I mean, you can walk away and come back in a day and a half and have your product. I could only do this size on my current printers. I could never even do the double. So I included the single just because I know not everybody has an XL size printer out there. So both of these are files that are for download. Now, we have our cubby. It's very easy. Well, we want to make a drawer that goes inside it. The cube that you used to delete this space on the inside, you could just duplicate that cube, and now you have the exact size of your drawer that comes out of here. You're going to want to shrink it just a teeny bit, but use the exact same one, just copy and paste. And then you do the same process again to hollow out the inside. Just shrink down that cube a little bit, hollow out the inside, and now you have this fun little drawer that you can do. And just throw another cube on the front and you're all good to go. Now, taking it a little bit further, just from our little cubbies right here, of course we added in mounting holes on the back here so that we can add our French cleats or just simply screw it to the wall. That way it is wall mounted. But what I also did was on this side, I put holes, and on this side I put corresponding hooks. So basically what I can do is I can put these together, and it is a very tight fit, so once I get them together they are not going to want to come apart. So bear with me here. Okay, so I have them together and now I'm going to slide it down, and now they are attached very securely. So you could keep printing, the individuals or the doubles and kind of make this as long as you wanted to put up on the wall. All right, so we have our cubby shelf system right here. It's hanging on the French cleats, so I can just pick it up and move it if I want to. There's actually a lot of weight in here. I have it filled with screws. I have it, my precision blocks and stuff. And then, of course, I have stuff on top acting like a shelf. So you could continue to print these again and again and again and just daisy chain it all the way down the wall if you want to. Have cubbies, have a shelf. You could even throw a light strip on the bottom of this if you make it really long, and then it'll illuminate your workspace right below. The best thing, though, is that this was super simple. It is very, very simple to make. Of course, I have the files for you to download, but you know what? Feel free to download those files and change it to your heart's content. I put no restrictions on this type of stuff. Change it, make it better, make much better ways to attach them to each other. Use it as a fun tool to learn from in your whole kind of 3D modeling journey. Well, we built our two holders. What are my final thoughts on the Elegoo Neptune 4? Like I said, it is cold here. I'm actually wearing like winter boots while I'm filming right now because my feet were just cold wearing my typical boots out here. And so the temperature swings that have been going through with this printer still being able to print well during that time has impressed me quite a bit. All of my prints came out great, and it just has that huge print volume that I'm able to use. If I had to give, some negatives, this is more of your older style type of 3D printer. And I did have to do a good job doing the leveling knobs when I first got this printer. So it does have auto leveling capabilities, but you still have manual knobs on here that for your very first time when you're setting this up, you really need to spend a lot of time, do a good job, and make sure that you level everything out perfectly. If you do, that is what will result in that I've had good print processes so far. So make sure you spend that time with this type of printer. But otherwise, very simple construction. I love that it has the added stability rails in the back, and it's just a good printer that's getting things done for me. So I'm very excited that, this is a personal one for me. This is going to be staying in the shop along with my other ones. That way I can start producing some big prints. So I'm excited. If you got some good content from this video, I hope you'll like and subscribe. Stay safe in the shop, and I'll see you in the next one.